To start, I am first going to list all the givens that we have in this problem. The first is that the skier leaves the ramp with a horizontal speed of 25 meters per second at an angle of 35 degrees below the horizontal. Because line Y over here and the imaginary horizontal line over here create a right angle, we can solve for that angle YD, which is this angle right here, by subtracting 90 from 35 to get 55 degrees. Next, we can also draw the gravity vector. And we can add that this vector also acts at an angle of 55 degrees from the line D. And the reason why is because the gravity vector is parallel to this line Y over here, and both lines intersect this line D. So that makes their angles, makes all their angles corresponding angles. So this angle right here is the same as this angle that would be between the vector G and this line D. Now, in order to solve for the line D, which is what we need for this problem, I'm going to redraw the diagram so that we treat D as a horizontal surface. From here, we can add additional information to the diagram, such as the angle from which the skier leaves the ramp and the vector for gravity and its angle with D. So I'm going to do that real quick. So here's the line D, but we treat as a horizontal line instead. And then here we have the gravity vector and its angle with the line D, and we have the angle at which the skier leaves the ramp. With this new setup, we can write our kinematic equations and solve for the length D. To do that, we will start with the equation for the vertical position of the skier relative to line D. When we set up this equation, we can then solve for T, and T represents the elapsed time of the skier's motion. In other words, the entire time the skier is moving. So then we can plug that into a equation for horizontal position of the skier relative to line D, and that will give us the position that the skier lands on line D, which will give us our answer. So to start, I'm going to write down equation 4 and plug in our givens to make our equation for the vertical position. Now plug in our givens. You'll notice that I did G sine 55 instead of G because, as mentioned before, our gravity vector is angled. So we only want the y component for our equation. So that's what the sine 55 represents. You'll notice I also did the same for velocity, our initial y velocity, because our velocity, as represented in our newly drawn diagram, the initial velocity is angled as well. So we only want the y component, which is the reason I put sine 35 down. So now I'll simplify the equation so it'll be easier to solve. So now to solve for t, we will subtract 14.34 to the other side and divide both sides by negative 4.10. And that evaluates to 3.50 seconds. Alright, so now that we have our time, we can set up our equation that represents the horizontal position of the skier, and then plug in our givens and our time, and then evaluate, and we'll get our answer. You'll notice that I'm using cosine now because that represents the horizontal component of the acceleration, and I'll also do the same for the initial velocity. This is 35. I'll now simplify and then solve for t. Not solve for t, plug in our time and then evaluate. That evaluates to 106.84 meters. And to specify, this is 106.84 meters on line D. So this is pretty much when the skier lifts off the, basically jumps off the ramp, her position, she lands on 106.84 meters down the landing incline. So yeah, that's the answer.